Yeah, okay, so we'll do this together now. All right. Beautiful, good. Here we go. So again, we have to get the LCD, okay? That's what we have to do. Now, we have x squared minus 9, right? That's one of the denominators, okay? But we have factored that before. We wrote it as x minus 3 times x plus 3, okay? That's what we did. For the other one, we factored that. You can factor that. That's really not hard to do. You have 3 terms. It's degree 2. The leading coefficient is 1, right? So from here, we get x squared minus 8x plus 15, right? We want two numbers whose product is 15. The sum is negative 8. Well, what two numbers do that? How about negative 5 and negative 3? Their product is 15. Their sum is negative 8, okay? From there, and also let me just say this, that, well, since we have the two numbers, we get x minus 5 times x minus 3. I don't know if I said this before, I might have, but since you have addition in front of the constant term, in other words, since this constant term, you have addition and it's positive, that tells you the two numbers have to have the same sign. Okay? They have to be the same sign. They're both negative or both positive. This here, the coefficient of x, if you have a minus in front of it, that sign tells you what the sign of the bigger number is. So 5 is bigger than 3, right? So its sign has to be negative 3. It has to be negative. So here we have a positive, right, in front of the constant term. That tells you both numbers have the same sign. They're both positive or they're both negative. The coefficient of x, we have a negative. That tells you the sign of the biggest number. So here it's negative. If it was plus 8x, the bigger number would have to be a positive. I hope that makes sense what I just said. I mean, if it doesn't, you could always just use trial and error anyway, because both numbers have to multiply to 15. The sum has to be negative 8. So, but anyway, you get x minus 5 times x minus 3, okay? And so we have our factorizations. We have x minus 3, x plus 3 times x minus 5, x minus 3. Okay, so from here, what do we get? Well, we have x minus 5, x plus 3. So the distinct irreducible factors are x minus 3, x plus 3, right? We have those listed. From here, x minus 5 we list. X minus 3 is already listed. The exponents, as you can see, they're all equal to 1. So the greatest exponent of each factor must be 1. It follows that the LCD is x minus 5 to the first, x plus 3 to the first, x minus 3 to the first. So all together, we're going to get this as our LCD. So that's what the denominator, we want it to be that. Okay. Okay, so from the first rational expression, 3x over x squared minus 9, well, we know that's 3x over x minus 3 times x plus 3. Well, for that denominator to be the LCD, right, we need the x minus 5 in there. That's not there, though. What do? We have to put it in. We multiply it. But remember, whatever you do to the bottom, you do to the top. So we get this over here. Okay. For the second one, same thing. I crossed this out because I copied the first line, and I thought I fixed all the rational expressions, but by mistake, I missed this one, so I crossed it out. But anyway, here, for the second one, we know this factored is x minus 3 times x minus 5. So we're missing x plus 3. So we multiply the bottom by that. But remember, whatever you do to the bottom, you do to the top. So we get this, as you can see. Okay? So before I keep going, are there any questions on this? We're not done yet with the problem, though, but that's okay. Getting there. Okay. So we want to subtract, right? So this difference equals this difference. And remember, since the denominators are the same, we subtract the numerators, like so. And when you subtract the numerators, right, since we want to simplify, we have to multiply these. So we get we have to carry out these products, excuse me. So for the first one, we know is 3x times x, 3x squared. 3x times minus 5 is minus 15x. Here we have a minus. So, well, the minus here we leave in front. For this product, we have 3x times x, 3x squared. 3x times 3 is 9x. Minus 5 times x is minus 5x. Minus 5 times 3 is minus 15. Okay? Notice I'm using parentheses because we have a negative here. We're subtracting, okay? We want to make sure we distribute the minus. In parentheses, the 9x and 5x we can combine, so I did that. Now I distribute the minus sign. And it's good to combine like terms. So 3x squared minus 3x squared, that's gone. Minus 15x minus 4x is minus 19x. We have 15 here. And this is our answer. Notice that this is simplified. I mean, hopefully it's easy to see that the numerator is irreducible. You can't factor it anymore. And since the denominator is factored, we can easily see that the numerator and denominator have no common factors, other than 1 or negative 1. So it's simplified. Are there any questions on this?
Can you just go back to the other slide for a second?
Like this?
Yeah, thank you. Let me just take a picture.
Oh, sure. I was going to post these notes as well, so.
Okay.
Yeah, but, you got it?
Yeah, I took a picture of it.
Okay. Yeah, but again, if I do go too fast, don't be afraid to say anyone, so I will not, get upset. Any other questions? Okay, so that's it for this chapter. What I'm going to do now is move on to chapter 8. Now, I'm not going to cover everything in chapter 8, though. Okay, there's no way, I don't have time for that. What I want to do instead, though, is what was I going to do? Oh, I was going to go through 8.1, which is actually a system of linear equations. Just get that. Oh, here we go. Okay, it's just saving something, then it will go through. Here, let me see if this will do it. Okay, there we go. Okay. There we go. Okay. Shit. Okay, good. So we're actually in 8.1, okay? Chapter 8. We're looking at a system of equations. In chapter 1, we did see, equations, right? Here we're going to see what's called a system of equations. So in a sense, we're kicking it up a notch, so to say, if that makes any sense. So we're going to see what a system of equations is. I'm saying we're going to study that, but it's probably good to know what it is. We're also going to focus on a system of linear equations. Okay? I mean, essentially, if you remember from 1.2 2, I think. No, not 1.2, but we saw equations in 2 variables, right? You know, something x plus something y equals a number. Essentially, we're going to deal with 2 of those at the same time. We're going to see how to solve such a system. There's actually different methods for it. There's substitution. There is graphically, which basically for us is going to be graphing it in Desmos. And the other one is elimination. So there's going to be 3 different methods for solving it that we are going to consider. All right, so, okay, so let's get some definitions here. Again, as I said before, so we're taking what we saw in chapter 1 and kicking it up a notch, so to say. Any collection of equations, though, in the same variables, that's what a system of equations is. Any collection of equations in the same variables. For us, we're going to look at a system of 2 equations in 2 variables. Looks like this. Here, A, B, C, D, J, K, they are constants, real numbers. A and B can't be 0 at the same time, and D and J also can't be 0 at the same time. Otherwise, one of these equations is gone, and we're back in chapter 1. Now, we want to solve such a system, but what does it mean to solve it? It means find a solution. Well, what's a solution to this? What does it mean what does it mean to have a solution to this? What is a solution to this? Well, by definition, a solution to a system of equations in 2 variables, x and y, it's an ordered pair of numbers that's a solution to both equations. That's just what it is by definition. So essentially, we're looking for a solution to both equations. That is, we're looking for an ordered pair of numbers that's a solution to both equations. Let's consider this system, for instance. 3, 1, the ordered pair 3, 1. Is this a solution? Well, if x is 3 and y is 1, right? In the first equation, we get 6 minus 1, which is 5. Okay, that's true. Awesome. What about the second equation? We have 3 plus 2 times 1, which is 5. But is that true? Yeah, that's also true. So this is a solution. It's a solution to both equations. It satisfies both equations. What about 4, 3? Well, in the first equation, if x is 4 and y is 3, that equation holds. What about the second one? Well, we have 4 plus 2 times 3. Is that equal to 5? No, it's not. So this is not a solution to both equations, so it's not a solution to the system. Okay, you know what? I'm going to have to stop here because we have less than 10 seconds left. So we will pick up from here next time, okay? Okay, so tomorrow, again, when the exam is posted, I will send out an announcement, okay? All right, let me stop this. So if I don't